Hey everybody, this is Larry. This is day 12 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join my Discord. Let me know what you think about today's farm. I'm in Mihara on top of a mountain. I forgot the name already because I've been hiking all day and it's tiring. But yeah, here in Japan, and that's all I have for now, so you can watch me solve the problem now. Hey everybody, this is Larry. You actually already know that I forgot I have an intro. Yeah, I'm going to start doing more vlogs, so definitely if you want to follow that adventure, I have a link below on that channel. Right now I'm in Onomichi, and yeah, let's get started on today's Leetcode problem. Today I went to do a bike ride, a very famous bike ride apparently in Japan, and I didn't take a bus, which is apparently on this one. So I'm kind of tired. And my voice is a little bit low right now today because I'm inside a B&B and it's later in the day and it's very quiet, and yeah, so I don't want to make sure I don't wake up anyone. So definitely my apologies if you have to turn off the sound. You have to. Hopefully tomorrow I'll return back to normal. Anyway, today's problem is 815 bus routes. You're given an array routes representing bus routes where routes of I is a bus route for the ith bus. Repeats forever. So 157 means okay, loops. You start the bus stop source and you want to go to the bus stop target. You could travel. Okay, so seems like that's the theme of this week, is the shortest path problems, right? It's a hard problem. Not quite sure why, but I guess we'll see. So it's the least number of buses you may take, and I assume they mean buses. They mean like doesn't have to be distinct, but So actually, you're trying to minimize not bus stops, but buses. Okay. Okay, so that means that, what does that mean? So basically, two routes or two buses have a path if they share at least one stop, right? And then basically just buffer search from there, right? I'm trying to think why this is like a hard, but maybe this is just an earlier problem where they think everything is a hard. Yeah. 10 to the 5th could be expensive. Oh, I was thinking about, so initially I thought it was something like, or not it was, but I was thinking initially something like for each two buses, do an intersection and then see what stops they have in common. But I guess what we can do instead is just build up that lookup table in a more straightforward way, right? So for example, now we can do something like, okay, n is equal to length of routes, say, and then now you have for I in range of n, you have routes of I, and then now you have for stop, I guess, in here. Maybe you have like a stop lookup, which is a dictionary of list, and then stop lookup of stop, we can append I, right? That means that now all the things in here are connected to each other, and then now we can, yeah, right? I mean, yes, but then now what? Maybe this is why it's hard. I'm like, this is easy, but then I can't, I'm not solving immediately. Okay. Well, everything in this stop, it's only at most 500 square, but can we avoid, how do we do it in a smarter way, right? How do we connect, like how do we create, do we even need to create that? Maybe not. I'm trying to think how this would work, or like, because a lot of my ideas, they can spiral into a big complexity if you're not careful. So I'm trying to think, how would you do that, right? So now we have to look up, but how do you how do you construct that graph? I've been taking a lot of buses lately here in Japan, but still it could be 10 to the 5th number of them. Because ideally, I think one thing that I'm missing, or I missed a little bit, is that the sum of the route's length is less than 10 to the 5th. So there isn't any shenanigans where every stop has every route. Actually, maybe it can, actually. Maybe it does deserve its heart, but okay, let's say we're at 15. What does that mean, right? That means that we could start off here or here. I guess the way to do it is actually not. Because once you've done a bus, you've done all the buses, right? Or all the things on that bus. So you never need to do that bus again. So I think you just remove stuff. I don't know, maybe that's a little bit magic. Right, so let's say you have a set, right? And then now, okay, let's say start is you go to source. Right? That means that, okay, so for stop in stop lookup of source, and technically it's not, it's lookup to bus, right? So this is a stop to bus lookup. Okay, so this is actually the bus, and then now routes of bus. Yeah, no, I think we're good. Then now we want to say, and this is a regular breadth first search, right? And now q.append bus with a distance of 0, or just bus, it doesn't really matter, because we can just do distances, and distances always have to be tied to a bus anyway. Right? Because yeah, you take the metrics is the number of buses you take, right? So okay, so then now distance of buses equals 0, right? And then now regular BFS stuff. The thing you want to do is that here on append, we want to remove it from future things, right? So for stop in routes of bus, we want to remove it. So stop lookup of stop, remove bus, right? So then now we don't have to look it up again. So then now every time you check out a bus in any way, then we also remove it from future lookups. That's the part that I think can get a little sketch. And if you remove it from future lookups, then you should be okay, because that means that now every bus stop can only be removed once. So that means that this is bound by a linear in the size of the routes, right? So yeah, so now, okay, right? And now for stop and routes of bus, let's say now we have a bus. So now we want to get adjacent buses, right? So we look at all the stops, right? Next bus is equal to this, right? If distances of this is greater than distances of current plus 1, then distances, and then now we queue this up. And this should never be smaller, because if it's smaller, then you already removed it, right? So I think that's maybe the big thing, is to remove the stops, right? Wait, what is this saying? No, this is an array, so sorry. So for m bus in this, that's why I was like, what am I doing? When you stop in routes of n bus, right? And then also, if stop is equal to target, then we return distances of current. And then now we can return -1. I mean, oh yeah, okay. I was worried about that. That's the part where I should wrote, this is where we should write a enqueue function. So something like that, right? And then now, I just suspected this would happen because, well, I mean, just kind of looked like that because you're iterating this and then you're removing it. I mean, the easy way to do this just I think this would work. Because now you're creating a new instance. Yeah, okay. I mean, it's not the right answer, but at least it doesn't crash. I actually was thinking that it may be too slow, but I guess that's fine. So source is 1. Okay. Why am I not queuing? Okay, so it looks at bus 0, bus 1. Bus 1 target 6. Oh no, what? Wait, what? I mean, it looks at 1. Oh, this is silly. Okay, it's still wrong, but at least it's sillier, or less silly. Actually, now this is right, because this is the number of buses, so this should be, I mean, this is wrong, but it's, I think, just off by 1. Let's give it a submit. I have some worries about time limit exceeded, but apparently I have something more basic. Oh, okay. Okay, so you don't take any buses at all, even though there's a bus there. Fine. That's a okay, fine. That seems like a gotcha, but alright, so not that bad. Apparently I got wrong answer last time too. There is the same answer. It is exactly the same input. What did I do last time? I guess I did it the same way. Except for I did it less complicated. I thought that may be too slow, to be honest. But yeah, this is just regular breadth-first search. The thing with the removal is that it guarantees, and maybe that it still is, but with the removal, it guarantees that each stop lookup is only used once when it's added, right? So that means that in the future stop lookups, where is that? It won't have that, all those items, right? So that means that everything here should actually, this will always be true, right? Oops, this will always be true for everything, I think, maybe. I wonder if that's true. Yeah, because of the removal, this will always be true, actually. So you don't even need, I mean, that if statement doesn't do anything. Or like, it doesn't, it's not that much of an optimization. But yeah. So then now it guarantees that that's linear time and linear space. Linear being the size of the number of stops. So yeah, let me know what you think. V plus year, if you want to say. Well, that's not even, I'm just being lazy. Linear is the number of routes or number of stops on the total number of stops on the route. And yeah, that's what I have for this one. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.